timeouts within our model. So what I'd like to do is to go to this model and now make these things timeouts, okay? So what we had here was a rate of 0.01 going from susceptible. I'd like to set a timeout with that same average time in the state. So given that this is 0.01, how long on average does one stay susceptible before getting infected? We said it earlier. 100. So let's change this to a timeout of 100. So change it to be a timeout and time 100. Okay? So now it's going to be exactly after 100 time. And the reverse, how long on average will you remain infected before transitioning back? 10. So that to a timeout of 10. Okay? So now we have a different set. Now, what should we see that's different? Okay. So visually, do you think it will look different? Okay. So this is what you should see. We're going to speed it up here. Come on. Hey. Hey. Oh, look at that. Okay, that was interesting. I thought we changed that to maybe let's go check that out. So this was a timeout there, and this was a timeout there. So they should be all in sync, in fact. Maybe I'll do it with the small pause. It's more easily visible. But what you should see is a blinking, sort of a blink. It can be okay. So this is sorry. It can be so you can in fact let's go try this right now. You can in fact have it be a timeout, but this could be drawn from a distribution. So now, what this is saying is you're going to be leaving at exactly a time, but the exact amount of time is going to be drawn from a distribution, right? That may be different for each person, for example. And we could have that sort of situation. You're leaving at precisely a time, and we draw it instead of from an exponential distribution, from a normal distribution, or from a beta distribution, or from a Poisson distribution, or what have you. Okay.
So when you said that,
yeah.
You said it's rate, it's
yeah, that's actually correct.
What would happen if it came out with a rate negative?
I believe it would transition immediately. And in fact, this could be 0, and it could be 0, and it'll transition immediately. I think the same thing if it's negative. Although, here, let's give it a try. Yeah. So right, if it was normal. Oh, look at that. Negative timeout. Okay, not quite so nice. I thought it would go immediately. However, let's give it a timeout of 0. See what you get. So you know what you would do is you would do a max of 0 and something drawn normal, say, to avoid that. Okay, so let's try this. Boom, boom. And timeout of 0, it should, it goes immediately. I think it was a display artifact. I think actually it was just trying to keep up with how quickly they were going. I mean, we should be able to. Let me do it. I'm going to do it with a. I sped it up hugely, and then it was trying to speed up. Let's do 10 for each of them, and then let's try to do this because they should all go in blank. I've run this thing. Okay, here we go. Okay, so I'm going to speed it up. So, and then. Oh, yeah, it's, I think it's just sort of catching up with all the events. Because actually each, it's scanning through the agents, and some of them go, logically it's the same time, but it's sequential. No, I think it's a display artifact. I think it's, in other words, they're occurring at the same virtual time, even though on the screen you see it you see it in the process of updating it, sort of as it's going through all the agents, and it doesn't go through them all immediately, but it displays them immediately. Yeah. Okay. So next timeouts.
Or to use the service agents in further calculations, then I would rely on the fact that it should be.
Yes.
We check that, right, by having it with trace,
Yeah.
trace line at the time.
Correct. So let's do that. I like the idea. So let's go back to that transition, and you say, and the time is, I think it's time. This is, what is this? What am I putting in here? What am I doing with trace ln? What is this thing? What am I doing with uniform when I am calling a method, it's called. I'm saying, hey, go trace ln, do this for me with this information. Uniform, calculate a value between this and this. Time, this is actually a method. It's saying, get me the time, fetch me the time. Let's go do that, right? So we're going to run this thing now, and if indeed this is correct, discrepancy, they should all go at exactly the same virtual time. True or not?
Even if you're at 500 or whatever.
Yeah. That's right. That's right. Okay. So I'm gonna stop this here, and I'm gonna just, things are printed what's called the console, and it's printed here, and you can quickly by inspection kind of see that it's all at the same time. You know? Yeah. So. Okay, so go to the experiment, and what you go to is model time, and you can see it says stop never, and start time and stop time. Yeah, and there's some more sophisticated things you could do, but yeah, that's the way. Okay, so I'm gonna skip over some things. So, right. So if we want, so we can have I'm not going to have you load in this model, even though it's provided to you. But one thing you could do is you could have something here have a rate or a timeout time. So for example, I could have this rate here depend on how long I've been in this state, right? So my chance of leaving the state depends on how long I've been here. And in fact, there's a way within AnyLogic to ask for how long I have been here, and I'm going to see if I can remember it off the top. It's called get. Let's see. So residence. No, it's. Oh gosh, there's something along the idea of residence time, but time and state. So I'm not going to remember it right now. I was hoping I would, but you could do that, or you could do it based on their age, for example.